Video, I'm going to explore various ways of processing graph queries on the server. And in this particular video, I'm going to use an SQL database as the target database, since that's very common in people's environments. You can actually use really anything on the server side. What you've got is a graph query coming in. So you should already be familiar with the Fulcro getting started videos and what the graph query syntax looks like. But many databases don't support graph queries at all, and even those that do aren't necessarily going to use the Datomic pull style syntax. Well, except Datomic. So there are a number of tools out here that you can use to satisfy queries, and they all have various pros and cons. And so I just kind of want to walk through some of them, but show you specifically how you can get from a graph query to useful results. So I'm using Fulcro SQL here, and most of the reason I'm using that actually I want to show you the graph query processing it has. But one of the big things that it does is it creates a component for you that gives you a bunch of development tool power. So I've got this schema in a migrations folder. It actually uses Flyway, so you could look up Flyway for Java to do the migrations, and you can version your database. The migrations will run in order, etc., etc. And so I've got an H2 database schema here with some settings, an account, to-do list items, invoice items, etc. Already set up and written. There's some other pieces I have to configure. I have to configure a connection pool. It uses Sakari CP for this, and so I'm putting the database in temp test. And then I have to configure the component to know this is the database name. You can have as many databases as you want. Here's where the pool is. Here's which database I'm using. Here's what the database name is, which actually isn't needed for H2. It's just only needed for MySQL. I'm setting it to auto-migrate and automatically create and drop the database every time, and then I'm telling it my migrations are on the class path. So that gets everything set up to where I can just start the database as a component. If you're interested in more details on using this in full stack development, take a look at workflow part 2 in the Fulcro playlist. I'm not going to do a whole lot well, I'm not going to show you anything with respect to using that in a real server. I'm instead going to show you how to use it within tests. So I've got Fulcro spec integrated with this project. And you can define a test suite in Fulcro spec. They're really just closure tests with some convenience macros around them and some tools. And this particular tool is a UI that will run in the browser. So you actually can run a server on a port, tell it where your tests are, where your source is. You can give it tags you can tag your tests with, and which of those tags are the default. So things with no tag are usually included by default. And I've got this set to automatically include any focus tests, and I'll show you this as we go. So over here, if I uncheck integration, nothing happens. If I uncheck none, actually, if I got the tests running, oh, I don't. All right, nothing's going to change if the actual test server isn't running. So if I hit reload here, it just can't be reached. Okay, so we're going to start the server tests. It'll tell me it's running on 8080. Now I can do that. Okay. So now, once it gets running, it has to tell me what the selectors are. I can turn on the integration tests, and you see they ran. Now they're not running. So I've got a way of choosing tests. The focused is just simply if I go to some test and throw focused on the end of any one of these on the end of its test, any of them that are checked will run. So it's just convenient for showing, kind of letting you concentrate in on exactly what you want. You can have, like I said, as many of those so you don't have to delete ones you want to keep. Okay, so step 1, I want to talk briefly about this tool that Fulcro SQL provides with database. Essentially, you give it a database configuration, which looks just like what you put in that config file I showed you a moment ago. Connection pool, which driver, etc. And it hands you back a migrated, running, connected database, essentially. If you're using something like Postgres, of course, you have to start the database yourself, but it's able to create, drop the database and migrate all the migrations into it. And so at this point, you've got this thing that when you leave this block, this with database block, the database will be cleaned up, right? So the connection will be closed and such. The database won't be deleted at the end. It's actually dropped at the beginning of the test, created at the beginning of the test, and that way if the test fails for some reason, you can go and analyze the database if you want to. The seed function is a handy part of Fulcro SQL as well. It lets you give it the connected database spec, a schema, which is primarily just used for the driver parameter, and then one or more seed rows or seed updates, where you can abstractly name which table by keyword, and even give it abstract IDs for the insertion that are then returned from seed in a map, so you can know what ID was used. So, just a quick raw JDBC example here, and this is Clojure Java JDBC. And this is handy when really all you want to do is pull one row. You've got some query. The query from Fulcro might be, hey, I want, account, or I want DBID and account name. Well, the thing that you need to return for that is DBID, some number, account name, some name, right? So that's all I'm demonstrating here with this test is, and down here I could, screw this up and see, you can see that the test fails. And every time I'm saved there, it's actually, if I clear the stuff down here, it's doing all of that database stuff. It's starting the pool, it's migrating things, it's clearing everything out of the database, it's running the migrations, and then it's running the test. So you can see that's just pretty darn fast. Of course, it's a really simple database, but keeping this light to where there's not a ton of data to deal with and focused is nice. So I recommend this sort of thing when really all you need to do is pull a simple query, because JDBC query gives you back things in a key value format where the keywords have already been set, and then something like set rename keys can be either mapped over that or just run on the single row that you're interested in to turn it into the shape that you want. So that's technique number one. Of course, that's not a graph, not much of a graph. It's at one level. But this is also handy when you've got some sort of complicated reporting where the query coming in is expecting some fairly complicated chunk of data where you want to write, you want to leverage all of SQL and do some aggregations and a bunch of interesting things and return that into some piece of straightforward state that maybe you even don't even bother normalizing on the client side. You just use it as this chunk of result data that you can render there. So I definitely encourage people to not overlook JDBC query or the Clojure Java JDBC library or libraries like it. Sometimes just hand processing it is sufficient and does a great job. But of course, we want to do a little better than that. So let me show you Fulcro SQL. So here we're going to, let me go to the schema real quickly. So I've got some to-do items. And so I've got a to-do list that has an ID and a name. I've got to-do list items, which have a label, which list they go with, and then if they have a parent, a pointer back to. So this is a self-referencing thing. So this is a to-do list that can be recursive in nature to any depth. Now, of course, this is something that I might actually want to put on the UI and I might want to query for in a nice nested form. And Fulcro SQL supports this kind of scenario very well. A to-one or a too-many join with the ID key on really either table. To-one, the key could be here. Too-many, the key could be there. And so this is what that looks like. So I'm seeding a to-do list, and I'm giving these, I'm kind of giving my IDs these names so it's easy to find them. So I'm going to create a list item at level 1, sublist item whose parent is item 1, etc. And my query for a non-recursive instance is just to ask for the list's ID, its name, and then its list of items, and they're labeled. A recursive query, I have to quote this because I'm going to use ... in it. is going to ask for the name, the items, and then within the items, their sub-items, ... So that'll go as deeply as necessary. The JDBC library has this with DB transaction that can set an isolation level, which is a good idea when you're walking a graph. And then I've just defined this simple little run query function in Fulcro SQL. Run query takes the database, in this case the one that's running the transaction, the database spec, the schema, and now this is important to Fulcro SQL. The schema in Fulcro SQL is fairly straightforward. We can say to walk from or to process this join key, to-do list items. It's a too-many relationship that goes from table to-do lists ID to to-do list item table to-do list ID. So that's the too-many relationship direction, and these are underscores, right? Because these are SQL table names, SQL column, SQL table name, SQL column. And then for the sub items, same sort of thing. It's a too-many going from to-do list item ID to to-do list item parent item ID. And so these are listed in the direction you want to traverse. You can do the reverse direction just as easily by saying something like, sub item, or you could just say actually to do item slash parent, right? And then it's just the same. This case it would be a to-1, right? Because a given item has one parent, and then you just flip these two. So you go from the parent item ID on the to-do list item through to the to-do list item that has that ID. So it's a pretty easy library to configure. It also supports custom configuration of converting what you want to say on the Fulcro graph to what the table and column name is called in SQL. And also, if you don't have ID as your standard primary key, there's a mapping for that. But I'm not using those right now because it's easy enough just to set them to the right thing. So you can see if I do simple list here, and again I'm seeding these, I get these back. I can destructure the IDs out of here. So if I had just say the number 1 on here, let me focus this test. And we can unfocus the other one. You can see that the ID was actually, I changed this one to 1, it was actually 6. So where did I do that? There we go. So you can see that this recursive list, which is running this query with this recursive query, which remember had the ... in it, starting at, so run query basically takes the database, the schema, what table and column you're starting at, the recursive query that goes with that as the starting point, and the root set of IDs that are these, right? So for running a query, you could have one or many things you're starting at, and then follow the recursive query from there. So for example, if I had more than one list here, I could put multiple list IDs here, and then I would get multiple lists back. So that's simple enough to show. So you see now I got a vector of lists, the things to do, and the other things to do. So that's just the root set. So Fulcro SQL works well when you have straightforward to-one or too-many joins in an SQL database that follow that normal pattern. You've got the foreign key on the source table or the foreign key on the reference table. Many-to-many joins are also supported. However, Fulcro SQL currently doesn't let you pull data from the join table itself. So if you go to back to the schema here, let's say I've got invoices, and so an invoice goes on an account, it has a date, and then invoice items is a many-to-many relationship, right? Because the item itself just has a name and an ID, and 400 different people could have put that item on their invoice, and so the item itself is the representation of the item, not the item on the invoice. So our invoice items join table here has how many items are on a specific invoice and which of the items has that quantity on the invoice. So this is a many-to-many join. And Fulcro SQL can handle everything except the quantity here. And so there are a couple of options you can use from here, and it could be that by the time you watch this video, Fulcro SQL has evolved and now supports that. But this is a great opportunity to show you yet another library called pathom. And there's actually a book for it. But this is a library that lets you design parsers for the query syntax that we're dealing with here. Okay, so, and I've got several demos, so let's start at the first simple one. So, pathom has this support called pathom connect, and connect lets you define resolvers that can figure out the data that's needed as the query is processed. So as it steps through the recursive query, it can walk external databases to fulfill elements, and it can actually fulfill those elements dynamically as it does that. There are also ways to deal with caching and such to help improve performance and things like over querying, but we're just going to show you some simple examples here to show you, one, how easy this is to set up and how powerful it ends up being. So in pathom, so we're pulling in pathom as P and pathom connect as PC. You create a parser and you can give it a number of plugins, and this environment plugin basically throws some things in the environment of the parser for all calls to it. And basically you set in the environment you set what things can be used to read data from databases, and if you're using pathom connect, you also have to put in, or you can put in, a resolver for resolving things that it doesn't understand yet. And then if you're using pathom connect, you also have to put in indexes to describe how the data is connected and resolved. So the reader here, map reader, as pathom works, it basically constructs maps for your entities that are being constructed during the parse. And so we tell it that the first reader is, well, if we already see the property there, just read it straight from the map. There's no reason to try to connect it and resolve it. And then this all readers reader is the thing that processes things through the resolver and the indexes. So this is consistent through all of the demos that I'm going to show you from this point forward in the video. So let's focus in on this guy. So now we're running this, and this looks just like the JDBC demo we had before. We're going to seed Joe into the database, and then we're going to, in this case, run a parser with the database in the environment and run that same query we saw earlier. We're going to ask for a specific user, right, an ident-based join, and these particular attributes, account ID and account name. And you can see if I go down here and mess this up, I'm actually getting that out. You can see that the testing support for Fulcro spec varies the IDs every time, so that I don't fool myself into thinking I've got it right when IDs happen to coincide. It kind of randomly distributes them. Okay, so let's see how this works. to define a resolver, the easiest way to do it is to define a multi-method. And the multi-method can dispatch on the resolver's symbol. So this is kind of consistent among all of the examples as well. We just define a multi-method. You could just use a function for this and dispatch with a case statement or whatever. And then for our default, we're going to say there's nothing, right? We always return a map from resolvers because resolvers are basically resolving elements of an entity that will be merged into the entity kind of quote so far, right? So if my entity had account ID on it and I was resolving account name, the return of this would feed into my resolver, which could then return account name, which then the resolvers would merge to end up with the final result. So connect kind of populates things in as we go. So our account resolver is going to take as its input an account ID. So we get the environment, which is going to have our DB in it, and the current entity, which we can pull properties out of. So we're going to make that a requirement that when we resolve an account, we have to have an account ID already, and then we can just run, as we saw before, JDBC query against that, using this result set function to just get the first one. And then instead of doing set rename keys, I can just literally plop the ID I already knew into this map and the account name in. So this doesn't look much different from the JDBC example yet, right? I did a rename keys here. Here I manually renamed them. Not a big advantage yet, and quite a bit more setup. So for this particular example, and then when I add a resolver, so we set up the indexes for pathom. I add a resolver. I tell it the symbol of the entity resolver. We use symbols to dispatch in pathom because we need to be able to serialize the indexes, and so we can't actually use a lambda here. So an index has an input and an output, and you can read the documentation on the book for exactly what these mean. But if I say I've got a single input coming in and then a list of fields that I'm sending back, then this automatically gets me a parser that can understand idents and queries around this particular property on things that have this property already. So I know that sounds a little confusing as we go through the examples. Maybe it'll become clearer. But down here now I can run the parser using the DB on an ident-based join, asking for these two properties. It understands that this is the ID because it's an ident with account ID in it, and account ID is an input. So it automatically understands that, and it gives me back the data that I want. Okay, so those are the basics of pathom. Now let's see example 2, where we see something a little more interesting in terms of these capabilities. Okay, so now back on the schema, our accounts have settings, and the settings, it's a 2-1 relationship, so we go from account to a settings ID, and then settings have auto open and keyboard shortcuts. We did this on the Fulcro SQL demo, and so this is what it looks like in pathom. We have the same account resolver. We didn't change that at all. Well, actually, we did change it. We're going to change the account resolver in the following way. We're going to say that on an account resolver, not only are we going to be able to return an account name, but we're going to turn account settings, where the only thing we're able to return from this resolver is the settings ID. So notice we're not giving it back everything that's in settings. We're just giving back the settings ID. Then we're going to change our JDBC statement to pull the settings ID because that's on that table. And then we're actually just going to return it in the exact form it should be returned for a Fulcro parser. Right? We've got account ID, account name, account settings with a submap with the property that we promised in the output setting of the resolver. So pretty trivial. Settings resolver we're going to build exactly like we built account resolver in the last example. Settings ID is the required input, and then the output are the things that can be on a settings row. And so We're going to use rename keys here because we're going to get auto open and keyboard shortcuts. So just like we did in JDBC example. Now, the cool thing is pathom connect can connect this output with this input. And it can even walk through multiple tables to do so. We'll see that in a moment. This setup is identical. And so now we can run a seed, put in account, put in settings, update the account to point the settings at the settings row. Right? There's a circular reference here, so we have to use an update to build that actual database, seeded database. We define a quick little run query function here that just runs the parser on a query so that we can go through and see that, yep, we can still find the account. And let me focus this guy. So if I screw any of these up, you can see that the test fails. So if I run a query on an ident joined to account name, I get account name Joe. I can find the settings. So if I run an ident base join to settings auto open, and of course I could also ask for the keyboard shortcuts, right? And I get keyboard shortcuts back instead. So I can run kind of arbitrary settings query, and I can now follow the graph to the associated settings. So I can run a query starting with account Joe, get account ID, account name, join on settings, and get auto open. So you can see we very rapidly can build up graph things that are quite interesting here. And now we have enough information to show you how we can deal with our many-to-many case that Fulcro SQL wasn't able to handle. So now we still have the account resolver. In this case, we didn't modify anything. We're still outputting the settings ID. Our settings resolver is outputting the same thing it did. No difference there. And now we're going to add a few more. So we're going to have an invoice resolver. Here, let's look at the specs first. The invoice resolver is going to take an invoice ID. So this is very similar to what we already had. And it's going to output two join columns on that invoice, the invoice account and invoice items. Now the invoice account, it's just going to output the ID just like our settings did in account, right? We output the settings ID. And we're going to output for items, well, in this case an invoice does have direct access to the item, so we might as well go ahead and output the various item details on the items on that resolver. This could lead to overquerying, and we could actually step this out one more and make an item resolver, but just wanted to show you you could do this as well. We're also going to add an account invoices that can go from an account ID and output an account invoices field. Now notice this is a separate account ID input from this one. We've got account resolver and we've got account invoices resolver. Two different ways of resolving attributes, and pathom can understand that I can start with an entity that has this, and this resolver will let me add this stuff, and this resolver will let me add this stuff. So they can be composed and connected in that manner. Settings resolver is no different than it was before. But like I said, the interesting thing is, one of the interesting things is the fact that I can have multiple resolvers with the same input that can augment an entity that's already been found. And then I'm going to add a more complicated resolver here. This is a global resolver. Notice this one does not have an input. This one, when you try to run it, it's trying to output the result of a join on invoices with item, where it gives back an invoice ID. So I'm going to be able to query this root level property, invoices with item, and I'm going to get back an entity that contains just an invoice ID. And of course, connect can then connect that to the input of other resolvers to give me details. So you can look at the various queries here, invoices that have an item. This resolver takes an item's ID in the parameters of the environment. So I've got a lot of destructuring going on here. So there's an AST in the environment that has params, and inside the params there's going to be an item key. I'm also still going to have the DB. here's the entity that's coming in, and I can select distinct invoice IDs from invoice items, where item ID equals question mark order by invoice ID. And the order by is just for my convenience in testing. So you can see for this one, this is basically give me the IDs of invoices that contain that item, which is what I want. Invoice resolver, this has to follow the join, because my input, remember, is the invoice ID, and so I'm going to have to join the invoice to invoice items to item. Relatively straightforward query to write, and then output what I said I was going to output. I'm going to output the invoice account with an account ID and the invoice items with the details of those items. So I'm just pulling that straight out of the rows that I'm JDBC querying for. So the resolvers for the individual bits are pretty straightforward. Now again, we would probably want to add some sort of caching in here, because if we do complicated enough queries, we might end up with a hitting this a query like the invoice resolver over and over and over and over again for single invoice IDs, which could be kind of hard on the database doing n+1 kind of query behaviors. And that's possible with pathom, but it complicates the code a bit here, so I want to keep it simple just to show you the power. And so now I just add those resolvers with their various inputs and outputs, and the inputs are straightforward sets of things, and our outputs look like queries, essentially, the thing that we'd like to generate output for. Same setup, and now we have a little bit more complicated seeding here. We're going to seed an account with settings as we did before. We're going to add a few items to the database, a couple of invoices, and a couple of invoice item rows, the join table. So invoice items 1.1 is there are 2 item 1s on invoice 1. In this row there are 8 item 2s on invoice 1. And in this row there are 33 item 1s on invoice 2. So we define this little run query function, and so now we should be able to start at some specific account and navigate to that account's invoices. So if we start at Joe, we ask for his name, some settings, invoices, right? We're composing all these different things from different places and ending up with the output that we expect here. A map that has his name, his auto open setting, and then the invoices that he has, 2 of them. The first one with widget 1 and 2, and again I could edit this to focus the test. And see that this is actually running live and all these tests are passing. So I can start an account, navigate all the way down through settings and invoices. I can find all the invoices that contain a given item. So this is our invoices with item query, where I'm parameterizing that with the item ID, and I'm getting that straight from the database seeding. This join notation, by the way, with putting parameters on the keyword of the join, is an easier to read version, but this syntax was not supported across the framework in Fulcro until 2.2, I think, and still isn't fully supported on Next. So be careful in using this. It's the official notation is to put the parentheses outside and the parameters at the end. But the AST has always supported doing it this way. It's just certain other utilities in Next don't work with it when you do that. So if we run the query starting or get all the invoices with item 2, we should get back just invoice 1. If I switch this to item 1, then you'll see, oops. Do I have item 1 pulled out? Oh, I don't. You'll see that I actually get invoices with items, invoice 20 and invoice 36. So I get both invoices if I ask for all the invoices with item 1, and I get just one invoice if I ask for them with item 2. And then I can also navigate backwards from an invoice to an account. So I'm going to do that same join with items, item 2, invoice account, back to account name, account settings, settings auto open. So you see I'm getting a completely different graph parse, where I'm starting at the invoice, going to the account, getting the account name. And so, all sorts of interesting queries open up very rapidly with a relatively small amount of code. And this gives you the power to really customize filling in your graph however you want. So it's a really cool library. There's one that's about to be released. At the time of this recording, wasn't fleshed out enough to include, but it uses pathom and gives you a little bit of pre-built syntax and such on top of it, so that you don't have to manually build these queries. And it's called Walkable in that library. Again, this is the end of February in 2018. That library might be available by the time you see this, but I hope I've piqued your interest and given you some ideas about things like using tests and some tools to deal with working through your database code, so you're not sitting and banging against a server and hitting reload on a client to figure out if your database code is right. Having seed utilities, but then the fact that it's really not very difficult to turn your arbitrary graph queries into something that can be consumed against a relatively normal database of really any kind.